Hey math fans, we're on section 2.2.2. Let's get started. The domain of a function is all the input values, which are the x values when we're working with a function. In this section, we're going to be discussing what is the domain of a parabola, but I'm also going to show you what is the domain of any function. Well, let's start with this weird function. What is the domain of this function? The first question you need to ask yourself is, how far to the left and the right does the function travel? Okay, don't pay any attention to the y values. We're only looking to the x-axis. We're trying to see what is the width, basically, of this function. So we're not going to look at the y values. And it looks as if the left side is at -5 and the right side is at +5. So we're going to say that the domain is going to be -5 less than x less than or equal to 5. Now, why did I put less than instead of less than or equal to for the -5? Well, the way the graph is written, there is a hole in the graph. Notice the hole on the left side of the graph. It's not a solid point, which means it does not include that point. So when it does not include the point, we're not going to say that it's equal to in the less than symbol. What is the range of the function? Well, now we're not going to look at the x-axis. We're going to only be looking in the y-axis. And in other words, we're going to be looking at the height of this function. What is the highest this function goes? What is the lowest it goes? And it looks like it's between -2 and +2. So we're going to say that this function has a range between -2 and +2. How do we write that correctly? So we're going to say that -2 less than or equal to f of x, which is y, less than or equal to +2. Now notice both of them are less than or equal to. And you might be asking yourself, wait a minute, you said that there's a hole in the graph right there. Yes, but there is an actual y value of -2 on the right. So that takes care of the hole. This function does reach -2 and include it. Parabolas are pretty basic when it comes to domain and range. Parabolas have a domain of all real numbers. They can go all the way to the left and all the way to the right. In other words, -infinity, less than x, less than +infinity. For certain word problems, though, we might be restricting the domain. Now, the range is always going to have either a high point or a low point, depending on which direction it's opening. If it's opening down, like in this particular example, the range is going to be y or f of x is less than a certain number. In this case, it's y less than or equal to 5. Example 1, describe the domain of the quadratic. G of x equals 1.5x squared. So for each one of these examples, for each one of these problems in the curriculum engine and your homework, we're going to be graphing it first. And after you've graphed the function, you're going to be asking yourself, what is the width of this function? And that will give you the domain, how far to the left and right. And you're going to notice that it goes all the way to the left and all the way to the right. So we're going to say positive and negative infinity for the domain, and x is in between that. And the range is f of x is greater than or equal to 0. Example 2, describe the domain of this function. Well, it's a parabola again, so we are going to say all real numbers, or -infinity less than x less than +infinity. Well, what's the range? Well, the y values don't go any higher than 0, so we're going to say y is less than 0, or f of x is less than 0. Now we have a word problem. We have to pay close attention. It says Amit's a diver on the swim team, and he's jumping off a 14-foot platform, and they give you the equation -16x squared plus 14, and it says how long will it take for him to reach the water? And what's the domain of the function? Well, first thing you want to do is graph the function. And so I've graphed it here. It's going to have a y-intercept of 0, 14. But the important thing here is that since time cannot be negative, we're going to have to restrict the domain. In other words, since we can't go back in time, x will always have to be greater than or equal to 0. Well, when will he be hitting the water? Well, when the y value is equal to 0, or when f of x is equal to 0. So we can go ahead and solve this equation here. We can say f of x is equal to negative 16x squared, and because we want to know when does he hit the water, we're going to put in 0 for f of x. Let's subtract 14 from both sides. And then we're going to divide by negative 16. I'm actually going to switch the x squared side, and you get x squared is equal to 0.875. And now we're going to take the square root. Remember, when you're solving for x squared, there's actually two numbers. When you square it, will actually equal 0.875. So we need to have the positive and the negative root taken. However, when we get down to the very end, we can't have a negative time. We can't go back in time. So the only solution that makes sense here is the positive 0.9354. That's going to be when he hits the water at 0.9354 seconds. So we can check our answer using Desmos. And as I plugged in the numbers into Desmos, we sure enough get an x-intercept of 0.935, 0. So what is the domain for this function? Well, it wouldn't make sense to have negative time. So we're going to say that the domain is 0 less than or equal to, because it could be equal to 0, 0 less than or equal to x less than or equal to 0.935. And why does the domain stop there? Well, because he hit the water. And that's going to do it for this section. We'll see you in class.